So let's talk about what is best, for example, when you have a mixed workload of I/O and CPU. And I/O intensive workloads, they typically have shorter CPU time. They do not require a lot of CPU time, but they require response responsive responsiveness responsiveness from the operating system. Because, for example, an IO bound application is something like the text editor you use, or your programming environment that you use Vim or or Eclipse or something. And if you look at this, they basically have to wait for you until you type. But once you type, you would want it to appear on the screen. You do not want there to be delays uh, between you typing and the text appearing on the screen. And if the editor is sluggish, you will be pretty unhappy with the performance. And there are a lot of these applications that basically have this characteristic of being I/O bounded, waiting for some input from some I/O device, and once the input is there, you would want to basically run it as fast as possible. Some other applications are CPU bound; they will just run on your processor for the coming 3 hours. So if you are into the simulation business, for example, and you are simulating a power plant, and the power plant will simulation typically would take a few days. Then if it takes a few days and 1 hour, it will not. I mean, if it takes basically 72 hours or 73 hours or 71 hours, you wouldn't really care, right? I mean, it you wouldn't. It doesn't matter. So you typically want your I/O bounded applications to be served as fast as possible, and they typically require very little CPU time. There are very few applications which can block on both CPU, or which can basically have be both CPU bounded and I/O bounded at the same time, right? Because any I/O operation will basically mean that you're going out of the processor, and if you're going outside the processor, then you might be dealing even with mechanical parts, and these are pretty damn slow for a processor, which basically makes almost I/O bounded applications very lightly using the CPU. So if you have a system that looks like this, you have some I/O bounded applications and some CPU bounded application. The question that all schedulers try to answer is how can you operate such that you provide both the I/O bounded applications and the CPU bounded application, the notion of fairness. And the notion of fairness is really hard to actually quantify, but you can think of it as, I mean, basically, in the case of the CPU bounded versus the I/O bounded application, uh, well, the I/O bounded application will need the CPU at any time, and it might need it a couple of times, basically in very short period, but then go and get blocked for a very long time. And in that case, would it be fair to make the I/O bounded application wait because it's not its turn on the processor, and keep the CPU bounded application running forever? Because that would basically mean that, well, your fairness is kind of skewed a bit, okay? Because you're in some sense giving preferential treatment to the CPU bounded application, because most of the time when the IO bounded application is scheduled, or I mean its turn comes basically on the CPU, it will not be able to use the CPU because it's, well, stopping for IO input still. So it just cannot run now. It's unrunnable. So, and now you have passed its turn and gave the processor to the CPU bounded application. Now it's again the turn of the CPU bounded application, and then the IO bounded application can basically remain for very long periods of time blocked, doing nothing, because it required the CPU for a few milliseconds, but you didn't release the CPU because it was not its turn. So the concept of fairness is really hard to quantify, and it's something that is in almost all schedulers try to apply some notion of fairness. And this is also important because you might try to game the scheduler by basically having a process, an application that just starts 100 threads, while you have another application that just has one thread. And these are competing applications, right? I mean, yes, they are running on your computer, but at the same time, each software developer has the complete. I mean, he really wants you to think that his software is kicks ass, right? It's really fast. It's blazing fast. I've never started that piece of software and had any trouble. But then, if the way the software developer is doing that is by basically starting 1,000 threads, thus acquiring a lot of resources unproportional to what is required by actually the application he has developed, then this will be a problem because it will starve all other applications. You might even start thinking that why is that application not really performing well? And in operating systems and in a lot of other systems, the way that fairness is imposed is using max-min fairness. And max-min fairness is a nice concept that basically says that you try to maximize the minimum allocation given to a particular process until all resources are assigned. I.e., if you have a process that has not taken enough CPU time, you would just assign it CPU time until it has uh, basically used the equal amount of CPU time to any other process without looking at its turn. And that would also apply for IO bounded applications. So suppose you have a CPU bounded application that uses the IO for very few cycles, basically, not cycles, but for very few milliseconds. It basically requires IO from some for some operations and midway before it finishes the operation. In that case, you would apply also the max mean fairness give the give uh, the CPU bounded application some time on the I/O devices. So you try to maximize the minimum allocation given to a particular process until its resources are until basically it has resources at the same level uh, of the other processes. And yeah, is there anything here that I have not said? And of course, I mean, max min fairness with round robin would always give you some sense of maximum fairness if you have very short cycle times, basically. Sorry, quantas. So if you have very short time slices, then you can basically have maximum fairness protocol using just round robin.